Welcome, algebra students, to Chapter 3, Lesson 1, Expansion of the Products of Algebraic Expressions, beginning on page 70 and going through page 74. We're going to learn about the expansion of the product of algebraic expressions in this chapter, like I said, but we're going to first learn how to obtain the product of two single terms. And we're going to go right to try it. So the situation is example A. So it's PQ squared times QR to the fourth. So here are the steps, and I'm going to take it bit by bit by bit. So the first step is you split this apart. So it's P by itself times 2 of the Q's, because Q squared is that. So that's the first term, times, because two parentheses next to each other means times, Q times 4 of the R's, 4 times 4 times 4 times 4. At this point, you combine like terms, so there's just one P, so it's P times all of the Q's. So there's 1, 2, 3 of them, 3 Q's times all of the R's, which there are still only 4. But notice you pick up the third Q from this value. Now you got them all lined up. So basically you have P, Q to the third, R to the fourth, at which time you drop out all of the multiplication signs. So P, Q to the third, R to the fourth. So that's how you simplify it. Now in example B, you throw in some real numbers. So again, you are going to combine, and we're just going to go straight to the combining part. You can combine all the like terms. So and it's all multiplying. So when it's written next to each other, like it is within these parentheses, that's multiplying, and then this section multiplies this. So it's all multiplying across, so you can start combining. So first of all, you combine the numbers, 2 times 7, and then you combine all the m's. Well, there's 2 of these and 3 of those, so it's 5 of them. 1, 2, 3, 4, 5, and then there's an n here and an n here, so there's 2 of them. So then you can actually do 2 times 7, so go ahead and do it. That's 14 times, there's 5 of them, m to the fifth, and 2 of these, m to the second. Then get rid of those multiplication signs. Your answer is 14 m to the fifth, n to the second. So that part is pretty straightforward. Again, remember, you can pause, rewind, listen again as often as you need for it to make sense. Now moving from here to the product of two expressions, we have to first of all review a distributive property. Remember, when it's a times x plus y, you're going to distribute the a to the x and then to the y, so you end up with ax, which is a times x, plus a times y. And then you can also do that to 3 terms, where a times x minus y plus z, you distribute the a 3 times. So first to the positive x, which is ax, and then to a negative y. So a positive a times a negative y is a negative ay. And then again, a to the positive z is a positive az. So that's just a quick review of the distributive property. And the class activity kind of goes ahead and explains that also. If you go on and turn the page to page 72, we are going to go right to try it number 2. And let me get this lined up properly. So try it number 2, letter A. We have y plus 1 times y plus 7. So what I'm going to do is I'm going to first distribute the y to the whole thing. That's what that arrow is. I'm distributing it to the whole thing. So purple arrow to the whole thing. And then I'm going to distribute the positive 1 to the whole thing, the pinks, y plus 7. Okay? So first distribute the y to the y plus 7, and then the 1 to the y plus 7. So basically you have this, y times y plus 7 plus 1, because it's a positive 1, plus 1 times y plus 7. So here, y times y is y to the second, and then y times 7 is 7y. Positive 1 times y is just a positive y. Positive 1 times positive 7 is just a positive 7. At this point, I'm going to, well, first of all, up here, what I did is I distributed this first and then that. You do it separately. You first distribute this and then you distribute that. Now you can combine any like terms you may have. I have two y's. I have only this value that is y to the second, so that stays y to the second. Then I have these two y values. So 7y plus y, which is the same as 1y, is 8y. And then I just have a single number, which is plus 7. So that's my expression. In expressions like these, you begin with anything to a power, and then you just work your way down power-wise. So the second, this of course is to the first, and then with no value, no letters at all, no algebraic letters at all, which is plain 7. That's as far as you can go. Can't combine or do anything else. Now in letter B, we're going to have 3z minus 8 times z plus 5. So I'm going to first distribute the 3z to the z plus 5. Then I'm going to distribute the negative 8 to the z plus 5. So 3z times z plus 5, and then negative 8 times z plus 5. And I'm just thinking of these separately. And then I'm putting it on, and then I'll do my combining. So 3z times z is 3z to the second. 3z times 5 is 15z. So do you see how I have to keep that z and that 3, and I have to use them both simultaneously at the same time. Negative 8 times z is negative 8z. Negative 8 times a positive 5 is a negative 40. Remember, negative times a positive in both cases gives me negatives. Now again, I combine my like terms, which in this case it's only these two, which are both ending in z. So 3z to the second stays the same. Positive 15 plus a negative 8 is a positive 7, because you subtract, but it's a 7z. And then negative 40 is by itself. That's as far as we can go. So that's how it works for try it number 2. Moving on to try it 3, letter A. Again, 5m, oops, let me get this lined up. I always kind of forget to do that. My apologies. Just want to get it all in here. Well, let's see. That should work. Okay, 5m plus n times 7m plus 3. So I'm going to first distribute the 5m over and then the positive n over. So it's 5m times 7m plus 3, then plus n, which is like a 1n, times 7m plus 3. So 5m times 7m. So I multiply the two numerals, 35, and then m's, there's two of them, it's m to the second. Then 5n m, I can't keep my m's and m's straight, sorry. 5m times positive 3 is 15m. Now, positive, so nice thing, it's all positive, so it's all going to be positives. So n times 7m, and it's just one of them. So 1 times 7 is 7, but now I need an m and an n. It's the only way I can write it. And then n times 3 is 3m. If you look here, I have an m to the second, a plain m, an mn, and an n. There are no like terms to combine here, so that's my answer. Going on to letter B. I'm just going to keep it in this order because I got it to the second, and then I have an m, and then I have the doubles, and then I'm just going to keep it in order. Our next problem, letter B, 3t minus 2x times 4y plus 9z. Notice how I try to write in cursive if I can. Sometimes the printing works, sometimes it doesn't. But those z's, for me, I always have to put a little slash mark because my z's and my 2's look the same. So I sometimes get mixed up if I don't do that. So anyway, first I'm going to distribute the 3t to the 4y plus 9z. So that's 3t times 4y plus 9z. Now I'm going to distribute the negative 2x to the same thing. So negative 2x times 4y plus 9z. So distributing these two, 3 times 4 is 12, and it's ty. I switch to cursive. 3t times a positive 9z. So 3 times 9 is 27, tz. So I got a ty and a tz. A negative times a positive is a negative. And it's going to be a negative times a positive again. So these are both going to be negative. So negative 2 times 4 is negative 8xy. And negative 2 times positive 9 is negative 18xz. It should be an xz. I forgot the x. Let's see. Can I squeeze it in there? I'm gonna. There we go. xz. So I got a ty, a tz, a xy, and an xz. So again, I have no like terms. So there I have it. Now try it number 4 gives us a situation where we can try 2 methods of doing the same thing. So first of all, we're just going to do what we've been practicing and try it 1, 2, and 3. Okay, so 2x minus 5 times 3x plus 7. So I'm going to distribute the 2x to 3x plus 7, which I did. Next, I'm going to distribute the negative 5 to the 3x plus 7, which I did. Then I'm going to go ahead and do that. 2x times 3x, that's 6x squared. 2x times a positive 7 is 14x. Got to keep, there's only one x. Now my negative 5 times this positive and my negative 5 times this positive, I'm going to end up with 2 negatives again. So negative 5 times 3x is negative 15x. Negative 5 times positive 7 is negative 35. Here I have a combination that I can combine. I have x's. So I keep my 6x squared, but a positive 14x and a negative 15x is a negative 1x, so I can drop the 1, so it's minus x, and then I keep my minus 35. Here's method 2. I just take my first value, 2x minus 5, multiply it by 3x times 7, and I just multiply like I would numbers. So first I'm going to go through with the 7, positive 7. Positive 7 times 5, negative 5 is a negative 35. Positive 7 times 2x is a positive 14x. I move 1 over because I'm going through the second time, so that's empty, just like multiplying. Now I have a 3x times a negative 5, which is a negative 15x, and a 3x times a 2x, which is a 6x squared. Now I add negative 35 and nothing is negative 35. 14x and negative 15x is a negative x, and nothing in 6x squared is 6x squared. So therefore, they both, I have to repeat it here because that's my answer. I guess that was my thinking there, but that is the 2 methods. So you can do it by the distributive property, or you can multiply it traditionally if you remember how to do 2-digit multiplication, which I'm pretty sure you do. Okay, so that was try it 3. I'm gonna have, try it 3. Actually, that was try it 4. How about that? Try it 4 continues with method 1, letter B. Hope I didn't skip anything. I feel like I did, but I don't think I did. All right, so method 1 is 2t squared minus 3t plus 1 times 3t minus 2. I'm flipping these things because I only want to distribute 2 items instead of 3. Does that make sense? So I'm going to distribute 3t to all of these, but then I'm going to go through and distribute the negative 2. With multiplying, you have that inverse property where you can flip the values. So proceeding, it's going to be 3t times the 2t squared minus 3t plus 1, and then the negative 2 times the 2t squared minus 3t plus 1. So here I go. 3t times 2t squared. 3 times 2 is 6. Now remember the laws of multiplication of exponents. T times t squared is t to the third because you just add your exponents. This is 1, that's 2, you end up with 3. Then you take 3t times the negative 3t. So 3 times negative 3 is negative 9, and that's t squared because there's 2 of them. Plus 3t times 1 is 3t. Doing the same thing, now I'm going to multiply everything by negative 2. So here's a negative and a positive, so my answer is negative. 2 times 2 is 4, t squared. Now I have a negative times a negative, which is positive. So 2 times negative 3t is positive 6t. And negative 2 times a positive 1 is a negative 2. Okay. Now I got to hunt for like terms. I only have one thing to the third power, so I list that first. Now I check for things to the second power. I have a negative 9t squared and a negative 4t squared, so I put them together. I have 2 plain t's, so a positive 3t plus 3t and a positive 6t plus 6t. I have one simple numeral, which is minus 2, negative 2. So now I do my combining. This stands alone, so 6t to the third. I combine my negative 9 and negative 4. 2 negatives is a negative, and I add negative 13t squared. 2 positives I add. 3 and 6 is 9, positive 9t minus 2. There's my answer. You can also use method 2 with this. Of course, you put the 3 valued figure up there, and so you only have to multiply through twice. So the first time through, I'm multiplying by negative 2. So negative 2 times positive 1 is a negative 2. A negative 2 times a negative 3 is a positive 6t. A negative 2 times a positive 2t squared is a negative 4t squared. I move one place over because I have my next place, multiplying through by 3t, positive 3t. Positive 3t times 1 is positive 3t. 3t times negative 3t is a negative 9t squared. And 3t times 2t squared is positive, of course, but it's 6t to the third. Then I add negative 2 and nothing is negative 2, positive 6t, positive 3t, positive 9t. 2 negatives is a negative. 4 plus 9 is 13, and it's a t squared. Oops, lost my cap. And then nothing in 6t cubed is 6t cubed, and that is my answer. 6t cubed minus 3t squared plus 9t minus 2. That is triad 4. Now, triad 5, we have a method 1, again, and a method 2. Again, use anything you want. Again, we have a confused order in this one, and you'll see what I mean. We have negative 4t plus 1 minus 3t squared. What's up with that? Usually you start with the t squared, followed by the t and then the single digit. And then here you got it flipped again. So 1 minus 5t. So first order of business, you flip them around so they're in order. Negative 3t squared minus 4t plus 1 times negative 5t plus 1. Then, because I only want to distribute twice, I flip them and put my negative 5t plus 1 first. And then I'm going to distribute that to the negative 3t squared minus 4t plus 1. And now I'm going to proceed like normal. So here I go. I am going to go negative 5t times that triple thing, and then I'm going to go positive 1 times that triple thing. And now I just go ahead, 5 times negative 3, or negative 5 rather, times negative 3 is positive 15t to the third, t cubed. Negative 5 times negative 4 is positive 20t squared. Negative 5 times positive 1 is minus 5t. Now I'm multiplying by a positive number, so my first thing is going to be negative, my second thing is going to be negative, and my last thing is going to be positive. So 1 times that, it's just going to be negative 3t squared. 1 times this, going to be negative again, negative 4t, and then positive. So basically 1 times anything is the thing. So it just stays. Now you sort it out again and realign. So I have 115t cubed plus 20t squared, and then so I have that here, and now I have my other 3t squared, which is also negative. So it's plus 20t squared minus 3t squared. Now I'm going to get my t's, negative 5t, negative 4t plus 1. Okay, now I just combine them, 15t cubed, so positive 20 minus 3, negative 3 is plus 17, so 17t squared. 2 negatives still keep it negative, so I add them, negative 9t plus 1, and there I have it. Now method 2, now I said we're going to use this formula, so it's already sorted, and I want this on top. I'm not going to use the confused order. I'm going to use this, okay? Otherwise, you're going to end up with a weird answer. So I just rewrote it like we are accustomed. First time through, I'm going to multiply this. Remember, anything multiplied by 1 is the exact value. So I just copy that down. So it's plus 1, negative 4t, and negative 3t squared. Move over for my place. Negative 5t times 1 is negative 5t. Negative 5t times negative 4t is a positive 20t squared. Negative 5t times a negative 3t squared is a positive 15t cubed. And then I add 1 and nothing is 1. 2 negatives is a negative, negative 9t. Negative and a positive, I subtract. 20 minus 3 is 17. It's positive because 20 has the higher value. T squared, and then nothing, and 15t cubed is 15t cubed. And there is my answer. And that is the lesson. Your assignment for tomorrow, it's a 2-day lesson, back to normal, 2-day lesson, will be on page 74 only. You will do number 1, number 2, and number 3, A, B, C. There you go. Number 1, number 2, number 3, A, B, C on page 74. Do good math. If you have any questions, please ask. Thank you.